case someone wants to access it later. Okay, Bismillah ar-Rahman ar-Rahim. Now, the other day we, we talked about some of the fundamental concepts when it comes to design, right? So we started off with a discussion on objects and classes, and we said that for an object you need to have three very important attributes, and those three important attributes are: you need to have an identity, it has a set of attributes, and it has a set of methods. And then we went on and we said that if you want to come up with a good design, you need to have, or you need to follow the very four fundamental concepts of design, which are the abstraction, encapsulation, inheritance, and polymorphism, right? And we covered the abstraction concept. Anybody would like to summarize what abstraction concept was?
Abstraction is to write with only the important things that your application concern about it.
True. So we are interested only in including absolute essential attributes and methods for our class, and we will be discarding any other information. So this is the first rule we should apply. Now remember, the reason we are talking about these four rules, and then we'll talk about some other good design principles, is that at the end of the day, when someone gives you a problem, a requirement set, you can design it in so many different ways. But one design will be better than other due to certain properties, and we are trying to now understand those properties one by one so that we can, as a designer, come up with good or excellent designs, right? So since we understand the abstraction, which means I should be including only those essential attributes and methods, the second concept I'm concerned or interested in is the concept of encapsulation. So I think we started this one. We can start it again. Encapsulation at the end of the day is all about putting them in different containers, in a sense, right? And not only putting them or grouping them together in different containers, but we are also interested in closing their lids as well, right? So we want to protect them as well. And this is the concept of encapsulation. The concept says all the idea is something, about something similar to this, which is basically you want the content to be together. So you want certain content to be here, and you want another set of content to be here, and another set of content to be here. And yet at the same time, you want to protect them. And this is what the encapsulation is all about. Now, this is different from abstraction, right? Of course, these four concepts go hand in hand. And when you're going to try and apply these concepts on your design, you will have to apply them together, and they complement each other. But there is no such thing as that, okay, for a certain design, I'm only going to apply encapsulation and I'm not going to worry about abstraction. No, it doesn't work that way. So as an example, let's see, we have these four set of attributes: account number, balance, then date opened, and account type. And we have another set of behaviors, which is basically focusing on opening account, closing account, and depositing it. We can group them together. So this is the first task, right? We can group them together in a class because they belong to an account, bank account class type. So if we group the attributes and methods together, that's the first thing we do. So this is the something, this is again first exercise of encapsulation, that you're grouping the right things together. And second is, we just don't want to group them together. This is not the aim. The second aspect is we want to really restrict access to the internal working of these classes or objects. So far, so good.
Yeah.
Okay, so there are two things for encapsulation. Yeah. One is to group them together, and second is to restrict their access. Okay. So the whole idea is all about information hiding. We want to hide data or information. The principle is very simple. The principal focus as an object should not reveal anything about itself. So this is our rule of thumb, that when you're trying to apply encapsulation, as a rule of thumb, you should not be revealing anything except when it's absolutely necessary for other parts to able for other classes and other objects to know this information, to access this information, to modify this information for application to work, right? So this is a rule of thumb when it comes to encapsulation. I want to group them together and at the same time, so something like this, I want to group them together, but at the same time, I want to make sure that only those parts are accessible to others which are absolutely necessary. Rest should be hidden. Let's look at this example. Have a quick read of this case and we'll discuss it. So if you have a bank account class, the one we had, there are different things we can do, right? One thing is that because of the encapsulation principle, we want to hide the information, which means we don't want anybody to come and just go on and change the balance, right? And let's see, if I don't apply the concept of this information hiding, and I have these two different classes associated with the bank account class, can they access balance? Let's assume there's no protection whatsoever. All of them are public.
Yes.
Yes.
Okay, now for example, this is class B, whatever, something like this. How I will, from a programming perspective, do it?
You would have an object of the bank account.
So I will have an object of this one, and then
You can access the balance.
I can access the balance. Right? Sorry, object of not this class, the object of this class, right?
Yes.
Okay. So, but we don't want to do that, because we want people to, for example, not access the balance at all. We want it to be only going through deposit and withdraw. What could be the reason we want to do this? Why you as a designer are interested that nobody should be able to go and change balance except going through deposit or withdraw method?
To make it easy, because whenever I take for example, when I take from the balance, I should like check the deposit and withdraw to check if I have balance.
Oh, yes. So you want to check some functionality, right? You don't want people to withdraw money more than they have in their balance.
Yeah.
Absolutely. So you want to put that functionality, and you want to make sure that someone's withdraws the money, it doesn't withdraw more than what it's supposed to. Any other reason as a designer you like to restrict this? That nobody should be able to go and access balance directly. It should all have to go through bank accounts, deposit and withdraw. What could be another reason?
There is a lot of reasons, but I think all of them or most of them are under security.
Yes,
or
so
they belong to security.
Yeah. So in other words, you want to secure your system. You don't want unauthorized accesses to your balance, right? Because it's just such a critical thing to your application.
Absolutely, yes.
What could be another reason? Can we think of something else, some other reason as well?
Doctor, I think the only possible two ways to change the balance is via deposit and withdrawal. So keeping the balance public for other classes introduces the possibility of it being changed without a valid reason. So the only two valid reasons is the deposit and withdraw.
True, absolutely, absolutely. And this is what you want to do, right? So, and again, this the reason you're doing this is because, again, what you're really applying is the concept of encapsulation here, right? The principle you're applying here is that everything should be protected, and I'll allow some things to be changed if it's absolutely required, and then I'll allow a mechanism through which it can be changed. So this is your encapsulation principle in action here. So as we said, one could be security reasons. Maybe you are trying to log, as we're saying, perhaps you want to keep an audit of who deposited money, who withdraw money. You want to make sure that only authorized people are able to do it. You want to make sure that, for example, people are not able to withdraw money more than what kind of account balance they have. So all of this is all about information hiding. You want to hide information, and you want people to be able to access this part of your application only through a certain authorized mechanism. Now, in addition to this, and all of them are, by the way, valid design decisions, and you're doing it to satisfy those design decisions. There are one or two other advantages of encapsulation as well, and it's a really, really very useful advantage in addition to what all we discussed. So, and I'll talk about this very shortly. So we can hide the attributes and control access to it. This is what we're trying to do. Encapsulation is saying control access to your data. Only access is from the object itself, So if we can deposit and withdraw methods from outside of the application, they can change the balance, but they cannot do it directly. So this is what we're doing. So we say, now we're gonna make balance private. Deposit and withdraw is the only way we're gonna allow the bank account to be accessible. And in other words, what we're really trying to do here is using the concept of encapsulation. We are trying to black box, right? We want to make this as a black box. Everything is closed. Inner functionality of that piece of code is blocked, and only few pieces are public, which we believe needs to be public, right? Like, for example, withdraw method and the deposit method. So far, so good. We can use the raise hand functionality. Okay, now, in addition to the different reasons we discussed a few minutes ago for making, balance private and making deposit and withdraw public, another possible advantage is that if you're going to make, by red I mean here that we have made them private, okay, so it's all protected. It allows us to hide the data, right? And the other classes which are there in the system, they don't really need to know how the balance is stored. In fact, probably we don't even want them to know how the balance is stored, right? So all the other classes who are interacting with the bank account class, we don't even want them to know how balance is recorded. It's all about hiding the data. It's all about information hiding. They can only do it through the withdraw and the deposit functionality. Now, another big advantage here is, which is just coming up, is that what if I change the way I'm storing balance, right? The requirements change, something else changed. I go on and change the balance, and I start, rather than recording the balance in a one single value, now I'm going to record the balance in dollars and cents. Am I getting any other advantage now because I made them all private? Do I need to notify all the other classes that, by the way, the way I was storing balance, I have changed it? Do I need to do this?
No.
Yes, of
Just
course.
have to change the methods.
I only have to change the methods, right? Because this is the only way. And for them, they don't need to know, because they know that if I want to change balance, I can change the balance using deposit or withdraw. That's it. Now, what is happening inside it? You have completely hidden it from the rest of your application. And this is another very, very good advantage you get when you do your encapsulation. And this is a very, very important design, quality you get out of it. I heard some comments like, others needs to know. Are they clear now that what exactly we're talking about here?
Yes.
Okay. So in a nutshell, if we change it and we change them to, rather than storing one balance account in a floating number, now if we're going to change it from dollars and cents, it will help us avoid the rippling effect of changes. We don't need to worry about making changes here or any other place of the system, because we have designed the application in such a way now, applying the encapsulation principles, we are hiding information, we're only making certain parts public, and we just need to make sure this part is adjusted accordingly for internal working of the functionality, and rest of the application don't really need to know. They don't have any rippling effect, so we don't need to worry about them at all. We only need to worry about one class, which is a huge benefit from a design perspective, because we know requirements change, we know system evolves, things will for sure change, and as a result, we want to make sure we do it in the right way. Now, I have a question for you guys. If I'm writing these classes, right, myself or maybe as a team, why I would like to hide my own code from myself or from my team? Why I'm supposed to do this? I trust my team. You know, why should I be even hiding this information from them?
Doctor,
Yes, please.
I think if a team is following a certain design pattern in their application, where different classes should not know about other classes, or different attributes may not be visible to other classes, I think making them private will protect the developers from accidentally accessing those attributes. Therefore, maybe creating a retain cycle, maybe like a strong relationship where the garbage collector will not work. So, or anything else, maybe just violating the design pattern. So this will protect the developers from violating the design pattern and making sure they follow the good design pattern.
Yep, this is absolutely true. Any other reason why I'm interested in hiding information from my own team?
For the
Doctor,
long
it can
term.
be for organizing purpose that we have mentioned. If I want to make changes, I will just make it in one place.
Absolutely. We want to organize this. We want to make sure that there's no rippling effects here, right? Anybody else? Yes, go ahead.
Doctor, you might be designing the product now, but you might not be maintaining it later.
True. Absolutely, spot on. So you want to structure them in the right way, right? So in a nutshell, actually, to be honest, the answer to this question is, if I'm writing everything myself, why I'm trying to hide it from myself? It's not about secret. We're not trying to be secret here, right? This is not the aim of encapsulation. We're not trying to be secret by making everything public or private, sorry, and protected. No, it's all about reducing the dependencies, as you guys said. It's all about reducing the dependencies between different parts of the application. And as a result, if I'm going to reduce my dependencies, I will minimize the impact of the change, right? So if I make a change at one place, if I have done and structured them in the right way, probably I will not have to make change anywhere else in the application. It will still work. And if I don't apply these principles, especially since we're talking about encapsulations, if we don't apply this encapsulation principle, then making a change in one place may have a huge impact all around your application. And if you have a large application, who knows what kind of bugs will be introduced and how you're going to fix them. All right. I believe everybody's on board with me on this, right?
Yes.
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 Okay. Now, the next question I have is, okay, I agree with you. You can say to me, okay, doctor, I agree with you. I need to hide it. I'm not trying to be secret. Now, the next question you can ask me, how much I should hide? What do you think? How much should I hide?
As much as you can.
As much as you can. Absolutely. I want to hide everything, to be honest, till to a point where absolutely I have to make something accessible to someone else in the application, which will for sure happen because our applications have classes and these classes interact with each other. So as you said, the rule is please as much as you possible. This is the principle of encapsulation. Hide it, make it private. Right?
Doctor,
yes, please go ahead.
can you give us an example of what kind of attributes that will we don't want to hide, or we want to make it public?
Okay. Now let's take an example of inheritance, right? Though we're going to talk about inheritance very shortly. So let's take the concept of inheritance here, and let's assume here, sorry, I'm just going to draw it on top of it. Let's assume in Java, of course, you can still do multiple inheritance, right? Of course, this is not a good thing, right? Now, would you be, in some cases, would there be a case where you like this attribute to be accessible to others?
Not really. We'd like to make it private.
Exactly. So, so the most of the time, even in these kind of scenarios, you will be interested in making, as a rule of thumb, you will say, I'm gonna make everything private, and only way they will be accessible through my methods. Now, the reason sometimes, and the example you're asking for is that sometimes, and I'm pretty sure all of us have experienced this during our development exercises or experiences, is that sometimes, we look for easy way outs, right? And the easy way is what? Make certain attribute public. Right?
So change it directly.
Change it directly. Like this is the easy way from a programmer's perspective, isn't it? Because
yes.
Now think from a programmer's perspective. Now remember, by the way, I'm going to talk about this as well, but it's a very good point you raised it here. Is that the design we are making is eventually going to be realized by the programmer, right? And
yes.
and as we said in the first week, in a very ideal world, it will be like one-to-one mapping, and this is what we're looking for. Now, the reason people start violating this principle, and usually this start happens at a coding level, is because if you want to follow the encapsulation in a right way, which is the right thing to do, you should be making all of these attributes private. And the moment you do this, from a programming perspective, you need to make sure that others are able to access it through their methods. And sometimes we kind of, find it difficult as a programmer, and we say, oh no, why don't I make this public and let it be open, and I can do it, the change anywhere I like, right? Which is of course a bad thing to do. But this happens. And this is something we're trying to avoid here. And by saying, oh no, this is not allowed, apply encapsulation principle, and this is which says make them all private. Right. So most of the time, it's, as a rule of thumb, the moment you're gonna say I'm gonna apply encapsulation principle, you probably will be making all of your attributes private. Right. Now, yes, please go ahead.
I have a question.
Yes, please.
Is getters and setters better than making it just public?
Absolutely. And this is the reason we do that, isn't it?
Yeah.
And that's exactly. So it's all of these are good, and the reason, to be honest now, why we do getters and setters, the reason we do it is basically for encapsulation purpose. See, this is the point. Yeah, this is the whole idea. The reason I'm raising these concepts here now is because I know some of these things you do as a programmer anyway, right? Yes, you go on and you've been taught in your 201s and 202s that go and develop setters and getters. But why? This is the question. Why you are interested in getting getters and setters? Because you want to protect your data, right? Anybody else would like to comment? There was a raised hand by someone, but I think it's down now.
Yes, it was me.
Okay, yes. Any question, please?
No, just where is the question that you mentioned?
Okay. Yeah, okay. Thank you very much. So because I'm actually sometimes I come back to this window just to make sure that I can see the comments. Okay. So everybody, I believe, is comfortable, right? We need to make sure this is a rule of thumb, and of course that's why we do hiding. That's why we use private. We want to make sure we have the setters and getters. Of course, different programming languages support this concept of encapsulation in different ways and different syntax. But regardless, the idea of encapsulation is that you enclose and encapsulate your objects, attributes, and methods. You want to close them. You want to hide them. You want to make them black box. You want to protect them. You hide everything about your object except what is absolutely necessary to be exposed. And as the question was, will there be a case where I like to have a public attribute? Answer is probably very unlikely. If you really follow encapsulation in a right spirit, probably you will never have attributes public. All right. So if I have to summarize encapsulation, the idea is very simple. This is actually summarized somewhere here in this key point. Use private, public, and protected keywords. So if you're talking about Java or similar programming languages, you hide everything as much as you can and only allow the parts to be exposed through public syntax or keyword where it is absolutely necessary for application to work, which will be a lot of cases, but you make your behavior attribute these methods available so that you change them, you update them, like the example we saw for balance of an account. You let the people change or let the other classes change it via a set of methods. Okay. Now let's move on to inheritance, which is the third part, right? Now, what's inheritance, guys? I'm pretty sure you guys have been doing inheritance from one of your one ICS 102 days. What's inheritance?
It's taking the attributes from a higher level class to other lower level classes.
Yes, in other words, from your parent class to your children. Anybody else would like to comment on it? What's exactly is inheritance?
Not only the attributes, the methods, I think, too.
Methods too. Fahad said generalization. Yes, absolutely. Absolutely. One lucky last comment. What's inheritance? Swiss generalization, as Fahad said. So let's move on. It's a great form of code you use. In other words, you don't want to have these methods and attributes all over the place again and again because they are common. So basically what you do is you create new class. Instead of writing everything from it, you basically go on and extend it from an existing class or your parent class. So if I have a person class and it has these three attributes, name, email, and phone, and it has a method called change email. And on the other hand, in my system, I also have something called customer, and it class also has three attributes: name, email, and phone number. And it has the fourth one, which is your customer number, and it also allows you to change your email, right? Can we start using some concept of inheritance here?
Yes, you can.
Okay.
You can delete name, email, and phone, and the method change email, and just inherit it from person.
Yes. So basically, by looks of it, we can say, oh, okay, I can, because they are common. Name, email, and phone are common. So let's make parent person as a parent class and customer as a child class, right? Now, why customer number? And I'm just deliberately asking this question, to be honest. Why customer number is not there in person? Because a person can also have a number, right? Why we don't have a person number here, for example?
This
Go. You go.
this person could be employee, and employee maybe doesn't need a number.
Okay, yeah.
The customer number, I think, revert to the ID of him in this.
In this context.
Yeah, in this context.
So let's say I have a customer and it's a customer ID. Let's call it ID, to be honest. That's actually a better word for it, right? So a customer ID, and as one of our friend just said, employee, for example, right? So employee can have an employee ID as well, right? Now, why don't I just have a person ID?
Because the customer ID is unique to the customer, and the person in general or regularly they don't have it for something. It must be associated with a job or something like interaction with the company.
Yes. Now we have a very interesting and spot on comment by Abdul Majid. Abstraction. Right? Thanks, Abdul Majid. Abstraction, absolutely. Remember, these four concepts will be applied together, right? And they never will be applied in isolation. So when I'm even talking about inheritance, I still have to keep in my mind the concept of abstraction and encapsulation. So customer, exactly the same. Of course, we know this, right? Only difference is this one. The reason we don't have customer ID or something similar in the person class is because of the use of the abstraction, right? Which all of you guys were saying, by the way, in one shape or another, right? We only want to focus on essentials. And for a person class, there is no such thing as person ID, hence I should not have a person ID. So what I was trying to force you guys as designer, I was telling you guys, because customer has an ID, employee has an ID, why I do not just add a person ID here and khalas, that's it. Get rid of these ones, right? And the reason is because you're applying the abstraction concept here, and person class does not have an ID, hence I should not invent it and put it here. Right?
Doctor.
Yes, please.
If they are all have some kind of ID, we should put it in person, right?
Okay, now that will be interesting if they are of the same type, right? They have the same kind of configuration, right?
Right.
Right. And of course, here we're talking about some very simple cases here, and we're just trying to understand the concepts here. Of course, this all depends on your requirements naturally, right? So if it is justifiable, because see, this goes back to the abstraction discussion we had on Sunday. For a given system, person may have a person ID, and for another system, person may not have a person ID, right? So both are correct in their own context, as long as you put the essential elements in your class. And this is all we are focusing on here, right?
Yes.
Okay. So we can use inheritance as we all agreed. Person class will become our parent class, and customer class will become our child class, and we can use the concept of inheritance to you make parent and child relationship. And of course, this is something we all know, that customer now has automatically all the attributes and methods of the person class. This is something you guys have been doing from your ICS 1 or 2 days. Only unique thing here is that customer has a customer number.
Doctor.
Yes, please go ahead.
Why the method isn't inherited for the customer class?
Good one. So why we have the change in email here, right?
Yes.
Okay, now this is a point I'll talk about inshallah in the next slide, right? So
Maybe
just bear
it's
with
not.
me.
Maybe it's just overwritten. Overwrite it. Change
Yes,
somehow.
yes, absolutely, absolutely, absolutely. So probably in this case it's happening, and this is something I'm going to talk about is the fourth level or the fourth important concept very in a moment time, inshallah. So can I be comfortable here that everybody is on board with me now, right? You can use the raise hand functionality as we agreed, just to get me a feel of it, because I can't see you guys, so I just want to make sure everybody is comfortable with the concept of inheritance. And this is probably the easiest one for you guys, but it has one important point. I'll discuss it in a moment, inshallah. Okay. Now, of course, the benefit here is that tomorrow, if I have an employee class, or the same system needs employee class, and it will still has the name, email, and phone number, and it has an ability to change your email. All you have to do is basically inheritance from the person class, correct? And it will have all of these attributes available to him. Plus, it has its own unique employee grade, for example, which is unique to it, and it has its own unique methods, join and retire, right? And hence you can structure them in a very nice way. So if you make a change in a person class, it will automatically be, so if you make a change somewhere here, right, you change the data type of them or something like this, it will be rippling effect and it will go automatically be filtered down to the subclass. And this is something you guys do it day in, day out. Now, before I move on to the next one, I would like to discuss one very, very important observation I have made over the years. And this inshallah will be discussed with some examples probably on Thursday as well, is that when you're using the inheritance, and I have another class here, for example, right, and I want to use association with it, or let's take this employee class as well, right? Why I'm not using association here? Why I'm using inheritance?
Because of the is-are relationship, because a person is
Yes,
an employee,
yes.
or an
Yes,
employee, I mean, an employee is a person.
employee is a person. In other words, basically, when you use inheritance, you want to make sure that all of your children classes and the parent class are of the same type. Okay. This is a very important concept when it comes to inheritance. You want to make sure all of them are of the same type. If they are not of the same type, don't use inheritance. And this is a very common mistake we do. A number of times we do this mistake, that we put an inheritance relationship where it's actually an association relationship. I will share some examples as we move towards these kind of very important design decisions. But I want to make sure you guys keep this in your mind that when you're using inheritance, make sure the classes are of the same type. You don't want to have an inheritance relationship where you have apples and oranges. Okay. Now this moves us to the fourth point, the fourth important design concept, which is the polymorphism. It's one of the most complex of the four terms in a sense, but it's very, very powerful. It lets you automatically do the correct behavior, and I'm pretty sure you guys have done this over the years. And even if you're working with one of the many types, so basically, you can be working with many different kind of function methods, and they might be doing different functionalities, but the programming language allows you this mechanism of calling the right function given the parameters. So for example, and this is a very simple example, everybody's comfortable and I think familiar with it, that when you are adding two integers, the plus sign has a different meaning. While if you're adding, two strings, it has different meaning, correct?
Yes.
Right. So polymorphism allows us to do this, that, depending on the parameters, it allows us to call the right function. and this is polymorphism. So you basically automatically do the correct behavior. Now, for example, we have this bank account. First of all, is this a valid inheritance relationship?
Yes.
Right.
Yes.
And the reason
Yes.
it's a valid inheritance relationship because the checking, the saving, the investment at the end of the day are all account types. So hence I can make this inheritance relationship. I have the same types of classes in the structure. Now, tomorrow, and it's very common that requirements change. And let's say requirements change now. And now in the beginning we were allowing the people to withdraw money from any of these accounts. Now we say no, you cannot withdraw money from your investment account, right? So you say no, if you're gonna withdraw money from your investment account, you have to pay penalty, right? Hence this withdraw function cannot be used anymore. We need to go on and override it, and we need a specialized withdraw what you call withdraw function for this investment class. And this is very common, by the way, right? So the good news is, yes, you can do it. No problems at all. The overriding mechanism will allow you to do that. All you have to do is basically change this functionality, and depending on the parameters, it will be called correctly. So basically, we can inherit whenever it's useful, and I can override the behavior when that part is useful. Polymorphism lets you work freely with the objects that have been created for any of these classes, right? And we all know this. So I can have an array of objects. So in other words, I can have a set of checking account objects. I can have a set of saving account objects, and I can have a set of investment account objects. Now, when I'm going to call a withdraw function on my checking account objects, this method will be called, correct? And when I'm going to call my when I'm going to call the withdraw function on my saving account objects, the same one will be called. While if I'm going to call a withdraw function on my investment, this specific overridden function will be called. And this is something we all know and do it. So in for example, our plus case, for example, when I'm going to call the function with the integers, it will add them up. When I'm going to call the functions with the strings, it will concatenate them. So polymorphism let us do the right thing at the right time. That's the strength of it. This is the biggest strength of it. But the point I'm going to raise now is I want your special attention for this. I'm pretty sure all of you know polymorphism, but this is the key point here. The point here is most of the classes do not need polymorphism, right? They don't need polymorphism. We don't have to go looking for polymorphism, right? In other words, what I'm saying here is that tomorrow you don't, if I give you a new system, a new requirements, as I'm going to do as a part of the project, you don't have to go and say, I need to have polymorphism in my diagram, in my design, because Dr. Sajjad said that, these 4 things are very key concepts. No. Polymorphism is something which happens naturally. Okay. So you don't have to go and invent and find places where polymorphisms can be done. No. It is an important 4 essential, it's part of the 4 essential concepts, but it only happens naturally, and it will happen naturally, and there you will use it. You don't have to go and look for it. Is this point clear?
Yes.
Yes.
Yes. So,
Doctor,
yes, please go ahead.
is polymorphism the action of overriding, or is it a general?
It is the polymorphism is a generic term which refers to an overriding, because that's very specific to the programming language terminology.
Okay, thank you.
You're welcome. So abstraction, yes, you have as a designer have to keep it in your mind. I'm going to use abstraction here. Encapsulation, yes. Inheritance, yes, you make sure you do inheritance in the right way with the same types. Polymorphism, yes, but it will happen naturally. Don't invent polymorphism in your system.
So, Doctor,
Yes, please.
is there a difference between two designers? One of them knows about polymorphism, and another one that he don't know about anything about it. He don't know even if it exists. Is there any difference?
Yes, yes. No, the biggest difference will be that, for example, in the same case, right? If I go back, for example, in the same case, what happened here? Come on. Sorry. Come on. It was supposed to be 23. Yeah. In the same case, for example, right? If he doesn't know that withdraw can be overridden here, then as a designer, because he realizes now that I need to do withdraw for investment account in a different way. If he doesn't know this, probably he will do what? What do you think we will do?
He will change the parent one.
Exactly. Either he will go on and change the parent one. This is one possibility, right? And then this is also incorrect because this means all of this will be changed, right?
Yeah.
Or he may break this inheritance relationship, right?
Yes.
Right, and make it as a self-contained class or something like this, and hence has all of these other functionalities written here as well.
Yeah, it's gonna be a mess. Yeah.
Yes. So yes, it is must. You should know it as a designer. But the key point here is that we are not gonna try and look for it as such. It will happen naturally. You will see it in front of you as part of your system design and requirement, and just use it. Okay. So I think it's almost 10:50 now. So I'll stop. I'll take the attendance first, and attendance is done. I'll stop the recording, and inshallah